If it can make ice.
Pick it up.
Oh wait, I forgot to get the paper.
Questions over the homework? Yes, sir.
No.
What did I miss Friday?
So Friday we did 3.13.
Gave you a cheat code. I did. Oh, so it's discussing it. It was a person of that. Oh, you can't mess with me.
Zero product property.
Oh, what? You grab it.
Questions over the homework?
No.
All right. What we're talking about today is factoring, a special type of factors. Difference of two squares pattern, or difference of perfect squares. Now, factoring does have a set, or kind of our steps, and we've kind of been going over those the past few days. Now, difference of perfect squares is unique because no matter what the terms are, our x squared term, our constant term, our first and third term are, they will always factor in this set way every single time. So it doesn't matter what the setup or the arrangement, it will work like this here. So the example they gave is this here, x squared minus 9. So we can find a and b. Because our a for this here would be x, and b would be 3, because what times itself is x squared? Well, that's kind of redundant. It is x. X times x gives us x squared. For our b, we're looking for what times itself is 9. That'd be 3 and 3. 3 times itself is 9. So we get a plus b, x plus 3, times a minus b, x minus 3. That's it. So,
That's all we're doing?
yes.
What the frick?
Let's look at this first one here. X squared minus 25. So again, it's still going to follow this pattern of a squared minus b squared is equal to a plus b times a minus b. Now there's a few things that tell us that this is a difference of perfect square. One is we have two things being subtracted. That's our difference. Now the question is, are two terms perfect squares? Something times itself. Well, what times itself is x squared? X. So that is a perfect square. 25, what times itself is 25? 5. So this indeed is a difference of perfect squares, because we have a difference of two terms, and both of those terms are perfect squares. So our factors are a plus b times a minus b. Well, our a terms are what? X and x. What are our b terms? 5 and I mean, we can have more factors, but about it. Because if we can find a and b, it's a plus b times a minus b. Now x minus 5 times x plus 5 is the exact same answer, because order does not matter for these here. Make sense? All right. We ready for the next one? So we do have a difference. We have two things being subtracted. 4x or 4z squared. What times itself is 4z squared? What are you saying? 2z. Because 2 times 2 gives us 4. Z times z gives us z squared. So 2z would be our a. Now what times itself is 1? 1. 1 times 1 is, so our b is 1. And our a squared minus b squared is equal to a plus b times a minus b. So for us here, our first set of parentheses would be what? 2z plus 1 times 2z minus 1. We're plugging in our a and b. Questions on this here? We ready for the next one? X squared minus 64. Most likely this is going to be a difference of perfect squares, because we do have a difference between two terms. What times itself is x squared? X. Now what times itself is 64? Okay. If we're not sure, we can always grab the calculator and take the square root of 64, because the square root of a number gives us a number that we would multiply by itself, because the square root of 64, we're looking for what number times itself is 64. Then it tells us it is indeed 8. So this is indeed a difference of perfect squares. We'd have our plus and minus. Our a term would go first, so we would have x and x. Our b term would go second, so we'd have 8 and 8. So we get x plus 8 times x minus 8. That's it. Questions on this here? We ready for the next one? X squared minus 36. We can say x is a perfect square, yes? It'd be x and x. X times x is x squared. 36, what times itself is 36? 6 and 6, yes? So how would this factor? X squared minus 6 squared. X was it? Times x minus 6. Or we could say that it's x minus 6 times x plus 6. We don't need both, we just need one or the other. Because whichever one we put as plus first or minus first doesn't matter, we just need one of them. Are you ready for the next one? Okay. This one does look a little different, yes? Same thing, it's just backwards, because our first term, 100, what times itself is 100? 10. What times itself is m squared? So this time our a is not a variable, it does not contain a variable, it's just the number 10. And our b term would be m. So it still follows the same pattern, just instead of having the variables in the first spot, they're in the third spot. Same thing, pattern still holds true. That's why this is nice. Pretty much, yeah. Yes. I'm glad y'all are understanding. Questions on this so far? Are you ready for the next one? 9n squared minus 16. 9n squared, is that a perfect square? What would it be? So it'd be 3n, yes? Plus, minus. What times itself is 16? 3n plus 4, 3n minus 4. Because we can still write it parentheses 3n squared minus parentheses 4 close parentheses squared, and then go to this here. If we see a and b and we know what a and b are, we can go straight to it. We do the a squared and b squared to give us an understanding of what a and b are and what goes in what spot. But if we understand how they work together, we don't necessarily need it. If it's helpful to write it with our parentheses squared and then go to factored form, do that. If not, you don't have to. So looking at this one here, 16h squared. What times itself is 16h squared? Yes. We'd have 4h. So that's 4h. 4h. We'd have minus and plus. I decided to flip them this time, but again, doesn't matter which one's plus, which one's minus. One of them does need to be minus. One of them does need to be plus. 49 would be. And 7. 4h plus 7 and 4h minus 7. And that's it. If we're solving for this here, we'd set both of them equal to 0 and then solve. Questions on these here? You ready for the last one? 25b squared minus 36. So 25 is 5 and 5. B squared is B and B. What times itself is 36? 6 and 6. Questions on any of this here? Let's do one more. I know it's not in the note sheets, but let's do one more. Let's see here. I think let's do 64 x squared minus. So I'm going to add one. 64x squared minus 144y squared.
It's like the same thing.
So 64, if we're not sure, we can always check. We can use the calculator. Because we can take square root of it. Because the square root, when we take the square root, we're trying to find what number times itself gives us the number inside the square root. Now we can do the same thing with 144. It is indeed 12. So this here, so 64x squared would be 8x. All right, guys. So it would be 8x and 8x. 144 would be 12y and 12y because we have y squared. So did that really change anything? Nope, and our signs would be. This one is a little different. Is there a greatest common factor between these terms?
Yeah.
What's the greatest common factor between 8x?
So it simplifies.
So it does simplify. We can move that 4 that's in common with both of these here. There, guys. So when we factor a 4 out, we're dividing both terms by 4. So if I divide the 8x by 4, we're left with 2x plus 12y divided by 4 is 3y. But if there's a greatest common factor of 4 and 1, it's actually going to be common in both, because the other 8x minus 12y has a common factor of 4, which would actually give us 4 times 4 is 'If we do have two things being subtracted and they're not perfect squares, look for a greatest common factor because there might be one that we can pull out that will turn them into perfect squares. Does that make sense? Okay. Questions on this here? Are you ready for the last part? Okay. The last thing we're going to look at today. Use the special product pattern to evaluate the expression 54 squared minus 48 squared. Because if we tried to do this by hand, the first thing we would have to do is find out what 54 squared is. That's a pretty big number. And then find out what 48 squared is and subtract the two. But our special product pattern, a squared minus b squared, is equal to a plus b times a minus b. Here, they already gave us a and b. A is 54, b is 48. So we could say 54 squared minus 48 squared is the same as 54 plus 48 times 54 minus 48. These are the same. And the first thing we can do is add 54 and 48. 54 plus 48, 102. 54 minus 48 is 6. And then we just have to multiply these together. Questions on this here? Are you ready for the next one? (68 squared minus 62 squared). So we're going to find this one here. We would do what? 68 plus 62 times 68 minus 62. So 68 plus 62 is going to be 130. 68 minus 62 would be 6. So we get 780. Questions on this here? I think looking at one more will be helpful. 36 squared minus 34 squared. Now let's start working it. 36, 34. Y'all agree? The last one's what? 47 squared minus 44 squared. Was it 42? 44.
So we don't even have to do that.
No, but I mean, if we didn't have a calculator, it does make it easier. That's it.